All right, welcome. This is a quick tutorial for loop basics in MatLab. We're going to break it down step by step, and here we go. So a for loop is used when you have a known number of iterations. Known number like 4 or 10 or from 0 to 10 in increments of 0.2, whatever. You know how many times you want to run this loop. So let's catch a series using the slope formula that we all know, y equals mx plus b, where x is a time interval. So jumping into part one, we're going to create a y-intercept, and then we're going to create a slope with these two commands right here. We're going to create a b, and we're going to create an m. So let's go ahead and do that. Y-intercept, let's say 10. And let's enter a slope, something positive 0.3649. Okay. Now that we have those two constants ready to rock, we'll go on to part two. Next, we need to figure out how many times we want to run this for loop for. So I'm going to run that as an input here of how many time steps, and then we're going to take that and put it into the line space function, which tells us from A to B, I want this many number of iterations as an array. So from 0 to 5 with 5 should give us 5. Let's try it out. Okay, so time is now an array that is, you get the size of it. I guess we could just go here. It's 5. It's a 1 by 5. So let's run that again, and let's give ourselves just a weird number like 17. No, that's too many. Let's do 7. Okay, so now we're going to run 7 time steps from 0 to 5. That gives us some nice irregular numbers there. If we pull it up, see time. Actually, I guess we would change that so we can get it as a vertical stack. Run that again, 7. All right, and then if we look at time, there we go. 1, 2, 3, 4, 5, 6, 7 steps from 0 to 5. Good. Next, we're going to create the loop. This is the actual for loop part. So we have these 7 time steps that we want to run through this loop. So because we're going to plot it afterwards, we're going to create these 2 empty arrays. Here, the y out array is going to be just capturing the solved value for the y equals mx plus b. It's going to capture the y values. And the y time array is going to capture the time interval and the y out value, which is going to make it easier for plotting later. So you're going to make these 2 empty arrays, and then you're going to create the conditions of your for loop. So we're going to say that for k equals 1 through the length of time. So let's go over here and check out what length of time is. So we're saying that k is equal to 1 through 7. And we know that if we made an array called GGG equals 1 to 7, comma 1, not comma 1, just 1 to 7, we would get 1 through 7. Or if we wanted it vertically, we just put the apostrophe at the end of it here. But we don't care about that. Okay. So k is going to be our arbitrary variable that's going to be 1 through the length of time, and we know that time is 7. So k is an array from 1 to 7. But it's not really an array, it's more the condition for this loop. We're going to run k iterations. We're going to run 7 of them. What are we going to do while we're running each one of those iterations? We're going to solve for this y variable, and y is going to be equal to mx plus b. And m we already chose and defined it up here as 0.3649, and b we already defined as 10 for our y-intercept. Those things are consistent. And now each time of k is the x variable. What this is saying is that for each time I run through this loop, each of the 7 times, the first time I want you to take k equal to 1. So that's going to be, if we just did time of 1, we'd have 0. And then on the second loop, I want you to use time of 2, and then time of 3. And see how we're increasing now. We're increasing with our slope here. And that is going to solve all the way through those 7 time steps. So it's not solving time times 1 times 2 times 3. It's solving for the value of the cell in that k condition array. Next, inside of this loop, we're going to fill up our empty basket arrays here. With these commands, the y out array is just going to be adapted to collect the y values on each solve, and the y time array is going to collect the time of k and the y's. So after that, we're just going to display this array that's capturing all of the data in the command window as a fancy table. So let's go ahead and run that. So at 0, y equals m times 0 equals plus b. That would just be 10, right? And then 8.33333, if we did, our m was 0.3649 times 0.83333, we'd get 0.3041 plus 10. There it is. And then if we did 1.6667 times 0.3649, 602 plus 10, 608. There it is. So each time this loop runs, it's solving for the y output based on the x value here, the time value. All right, and if we want to plot it, we're just going to create a plotting variable. We're going to plot our x values of time and our y values of y out array. That's why we captured those separately. We captured the y out array as itself. And then we're just going to put a couple of parameters on here. We'll make the line a little thicker, make it dotted so it's easier to see, give it an orange color. And then we're going to give it a title. This is just output over time, where y was the output and x was t time. And then we have some visual parameters. We set the background color, and then we set the size of the rendering window here, and we turn the grid on. Next, we create y and x axis limits. So the axis command here would just be from x0 to x1, like from 0 to 10, and from, I don't know, 10 to 100 over here. But in our case, we're definitely going to go from 0. We're going to go to the end of the time array, which was, I think we set it at 7. And then y0 is going to be our first lowest limit on the y-axis, and I'm setting that to the y-intercept -2, so that we have a little barometer there. And y out array end, the end of it +2. That's going to give us a nice set of axis limits for the set that we put in based on that 7-step time array. And then we're just going to label the x and y axes. We have time in seconds and the output in whatever unit it would be. So we run that, and we get this array here. We started at 10. We get that slope of 0.3469, or 3649, yep. And then at 5, it finished here. And that's how you do for loops. It's based on the number of iterations that you want to run through, an output value that you're looking for, and then you can choose whether or not to capture them in an array here. All right, that's it.